Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, saya Muammar Sadrawi. Saya dosen Manajemen Universitas Scientia Internasional Indonesia. Pada kesempatan ini saya akan membahas salah satu mata kuliah yang saya ampu, yaitu Artificial Intelligence in Life Science dengan bobot 3 SKS. Video ini dibuat sebagai salah satu persyaratan sertifikasi dosen sesi 1 tahun 2026 pada bagian penyusunan pernyataan diri dosen dalam Unjuk Kerja Tridharma Perguruan Tinggi. Mata kuliah AI for Life Science ini merupakan mata kuliah wajib untuk mahasiswa semester 6 yang mengambil streaming bioinformatika pada program studi bioteknologi dan biomedis, dan merupakan mata kuliah pilihan bagi mahasiswa dari streaming lain pada program studi tersebut. Adapun bahasa pengantar yang digunakan adalah bahasa Inggris. Mata kuliah ini bertujuan untuk mengenalkan mahasiswa mengenai konsep dasar, metodologi, dan potensi kecerdasan buatan pada sistem kesehatan. Mata kuliah ini akan membahas beberapa metodologi kecerdasan buatan, seperti klasifikasi dan regresi, dan aplikasinya pada dunia sains. Setelah mengambil kuliah ini, diharapkan mahasiswa dapat mengimplementasikan metode kecerdasan buatan pada aplikasi ilmu hayati yang lebih luas. Adapun capaian lulusan yang dibebankan pada mata kuliah ini adalah 1. Merespon dengan ketangguhan. Lulusan mampu beradaptasi terhadap tantangan lingkungan baru dengan ketangguhan. 2. Mengoptimalkan kolaborasi. Lulusan mampu bekerja dan berkomunikasi efektif dalam tim yang beragam untuk mencapai tujuan bersama. 3. Diversifikasi bioproses. Lulusan memahami prinsip rekayasa bioproses dan mampu memilih teknik yang tepat untuk bioteknologi industri. Yang keempat, bioproduksi terapan. Lulusan mampu mengembangkan dan mengoptimalkan sistem bioproses, melakukan scaling up, mengevaluasi kelayakan produk. Dan 5, menerapkan analisis sains data. Adapun bobot penilaian mencakup tugas individu sebesar 30%, presentasi sebesar 30%, dan semi-independent project sebesar 40%. Sedangkan untuk capaian pembelajaran mata kuliah meliputi 1. Memahami modalitas data ilmu hayati. 2. Menguasai pra-pemrosesan data biologis. 3. Menerapkan model kecerdasan buatan pada data biologis. 4. Mengevaluasi dan memvalidasi model kecerdasan buatan secara ilmiah. 5. Merancang model kecerdasan buatan secara utuh. Adapun materi pembelajaran yang digunakan adalah 1. Penggunaan konsep kecerdasan buatan. 2. Perbedaan variabel penting dalam ilmu biologi yang diproses dengan kecerdasan buatan. 3. Identifikasi variabel penting pada aplikasi ilmu biologi. 4. Studi kasus. Sistem pembelajaran yang diterapkan merubah tatap muka dengan metode pembelajaran berupa teori dan aplikasi dari kecerdasan buatan. Pada kesempatan kali ini saya akan menanyakan cuplikan video pada sesi kedua, dan adapun Sub-CPMK yang ingin dicapai adalah mahasiswa dapat mendesain model jaringan saraf buatan multi input single output dengan menggunakan bahasa pemrograman Python dengan indikator utama yaitu ketepatan dalam mengimplementasikan model jaringan saraf buatan dengan Keras TensorFlow. Demikian informasi yang dapat saya sampaikan. Berikut merupakan cuplikan video dari salah satu kasus pembelajaran pada sesi kedua. Selamat menyaksikan.
Okay, good afternoon everyone. Today we are going to go by session 2 for the Artificial Intelligence in Life Science classes. And this week we are going to learn about the artificial neural network. So in bahasa, this is called jaringan saraf buatan. So it will be working like the saraf, how the jaringan saraf works. Okay, so we are going to have several parts. Actually, we have 2 parts. So initially we are going to have the part 1 for the theoretical of the artificial neural network. Then we are going to the next part, which is the practical of the neural network. Sometimes if neural network it is called ANN, artificial neural network. Then the second part you are going to go by the Google how we implement the practical of the artificial neural network in the Keras TensorFlow. And then this week the learning goals will be the student able to design in multi inputs and single output easy practice. So this kind of system that we will have several inputs, then we will need to predict what okay. And then in the rest we are going to use the how is the accuracy in implementing the artificial neural network model with the Keras TensorFlow. So actually this is a module from the TensorFlow. TensorFlow is by Google. So 2 main modules familiar, they have TensorFlow and not more is PyTorch. So if you know the YOLO that test for the PyTorch one, okay, PyTorch, I think by Meta, so TensorFlow by Google. These two the biggest modules for the AI Python. Okay, and then here are two books actually that you can learn. You can use these two books. The first one is from Haggard. This is very famous neural network books, but this will be under the matrix space, and this one is Artificial Intelligence Applied to Intelligent System. This is from Nektemetsky. This is also quite easy to go where take is from very good university too. And this book is quite very straightforward, not heavily on the matrix space, but this book is quite easy to be followed. Okay, we'll start by introducing the brain and neuron work. That actually the brain and neuron or brain specifically consists of the many highly connected elements, the power of 11, and then it is called neurons, and some parts they will get like dendrites, cell body, and axon. So dendrites is the three like receptive neuron or nerve fibers carry the electrical signals. Meanwhile, the cell body will effectively sounds and transform the incoming signals given by dendrites. Meanwhile, the axon, here is the single long fiber that carries the signal from the cell body to the outer neurons. And then the point of contact between the axon and one of cell and the dendrite of the another cell is called synapse. Okay, I think that's the biological skill quality of earbuds. And then we start by producing a simple model for the ANN, artificial neural network. So we will have E as the input, which is synapse here, and then multiply by W. W is weight. Okay, and then another part will come to here, which is bias, and then the summation to just the simple summation plus goes as the dendrite, and then these two inputs for weights and bias will generate the end. Okay, and then we have F which is the transfer function. I will be telling you then what is the transfer function, and we'll get A. Okay, then actually A is equals to the function, the transfer function of WP plus D. Okay, if I skip F, we just have WE plus B. So A equals to WE plus B. One is this equation, WE plus B is similar to, say remember, WE plus B plus AX plus B, linear regression. Yeah. So here is the linear regression part. Yeah. LX plus B. We have LX plus B. But after that, we need to calculate the transfer function. Okay? Then actually, to get A, you will need to have transfer function of WP plus UG. Yeah? So for example, we will have the W equals to 3, P equals to 2, B equals to minus 1.4. Then, very simple calculation, 3 multiplied by 2 minus 1.4. Sorry, 1.5 or by pi. Then we will get the transfer function of 4.5. Okay? So the patient. So at this point, we will need to get 4.5. But this is not solved yet because this 4.5 is still heavy. Okay? We did not get the A yet. Yeah? So we'll need to get 4.5 on the transfer function of F, then we'll get A. Okay. Then what is actually the transfer function itself? This table is just have many mathematical equations, but we can take one example, maybe and limit the first one. 4.5, right? We need to calculate the A, right? So if we see the transfer function, A equals to 0 when n less than 0, right? A equals to 1 when n greater than 0, right? What is our n frequency? 4.5, right? If we get n equals to 4.5, what will be A? 1. Okay. If we have A equals to minus 4.5 and minus 4.5, what will be A? 0, right? So that's the transfer function. So normally having 4.5, which was the n actually, we'll need to put this 4.5 to the transfer function. If you use the hard limit transfer function, the n, which is 4.5, become 1. Right? If we have n minus 4.5, A would be 0. Actually telling you, if you have the value of n greater than 0, then you will get 1. If less than 0, you will get 0. So you can see the icon here. Right? So they will have either 0 or 1. Yeah. So they will be in between of 0 to 1. Okay. However, if you have linear 1, if I have m equals to 4.5, what will be A? It's 4 point. If I have 10 equals to minus 4.1, what will be A? Still minus 4.5. Okay? That's it, the transfer function. Actually, the transfer function is another name for another function here. So they just transfer your n to A. Okay? So this is called transfer function. When you get n equals to 4.5, it's still 4.5. But if I have n equals to minus 4.5, what will be the result? Yes, that's right. So currently, this is very similar to what today's called rectified linear union. So when you get the value less than 0, you will be 0. But if you get positive 1, you will get that value itself. So if you get minus 10, still 0. Minus 100 is still 0. But when you get 1, that the A tiba. And you get 2, A. So they trim the Bagai and the loss of 0. Okay, 0 is super short. Lower than that, we just it. However, in our equation on next example, we are going to have like this value. We have f equals to 1.6. Okay? And then we need to calculate how is the hard limit linear logs point. So we have the previous table. We know how is the hard limit, how is the purely, how is the loximoid. Loximoid is very famous. You just get put to this option. Then you get the value. Right? This is quite simple, but yes, when you see this table, this is just looks complicated. But if you see one by one, it should be there. Hey. Then we are going to see this, the same like the table. This looks very complicated. However, if we see one by one, you see P, yeah, you see summation, you have B1, you have N1, you do transfer function, you get A1, which is the same like we discussed before, right? And then we repeat. The second one, we will have P2 goes to period, we have V2, B21, N1, 2, transfer function, we get
A1 to the same like this one, okay? This is the same like this. This is also to be the same. But what makes this complicated? We just need to do very similar mathematical equations, but in very big equation. So, the hack computer, we can use hand to calculate this, but when we have thousands of these, you cannot use hand. Okay, in neural network, this is called layer. Okay, this is called input, this is called layer, and the third layer, the last third layer is the output. Okay, you are going to have the input and then processed by the neural network, then we will get output. Okay. I told you the one equation, the rest will be computer there, so it for us. Okay. If you see from here, the equation is quite big, yeah, but this is not as copy case or PK. You get to see from inside. Okay, we have W1 T1 plus B1. This is the same like we got page 4, right? And then if this goes to the transfer function, that this will be one value, right? So one input to here will get output to here, right? And then this output will be input to another next layer. Okay. The output from the previous layer will be the input for next day. The same. The input from the previous layer the output from the previous layer will be the input from next layer. Okay. So this will be X for the next layer. Okay. And that this will multiply by W plus B will be the output, yeah? But this output will be the next input for the last layer. Okay? They kind of like changing everything from the layer 1, layer 2, and the layer 3. Okay, today we have a question first. If you since that's the simplified one, so we go to CE. This is the input multiplied by transfer function becomes the output, and that is to the transfer function become another input from next coming layer, and then this become another input for the last case. The math is quite simple, but so many things you need to calculate. Okay. Okay, and then I'll go for the second part. So after understanding the theory, then you go for the next, which is the practical of the neural network. So this is the data that we are going to use. So we have 4 columns here, because you remember that our topic will be using the bulky inputs, one single output. So I will select first 3 columns as our input, plus column will be output. However, if you see the data, we can see, is there any correlation between columns? See the data? Huh? Sorry. Random data? By the way, not really random. There's still any increasing by 2, but there will be some randomness there, because you can see 6.9, 8.9, 10.9, and 12.9. Yeah. Actually, initially I'll make just I plus 2, and then I plus score 5 plus 6. Yeah. I'll just try to make very simple data. I want to see will I be able to see the factor. Okay. So I will be using first, second, and third to predict the last one. So initially I need to import the keras one, which is from the TensorFlow. I will need some help from NumPy, and then I will use the sequential part, and then some dense layer. Dense layer, that's specifically called the neural network.
And then I'll use the optimizer of repeat square propagation. I'll get NumPy to read our data, and in somehow I'll need to use pandas for the table. So I will read the data from this file drive and so on, CSV file. And then can see my X will be the first 3 columns and Y is the last one. So I have several layers here. First layer contains the neurons of 1 by 8, the tab 1. And then the second one will be 64, next one will be 32, the last one will be just 1, because we are going to predict just one value. Okay, so 1 by 8 reduced to 64, reduced to 72, 6 to 1. Okay, then you see here the activation equals to REU. This is the task of action. This is what our task of action. The REU that I just told you, if you get minus 3 it will be 0, minus 4 will be 0. If I get 2, still 2. If I get 3, still 3. So it will be get. Okay, then I have 3. What is this 3? Then it puts that those 3 columns. Okay, what is 128? The first layer. So you see, this will connect to this, and I'll get this 1 by 8. Okay, the output is become 128, and then this 128 goes to 64. Okay, and then this 64 will be 32 here. Yeah, 64, 32. And then 32 will become 1. Okay. So 3, 128, 64, 32, and 1. Yeah. So that's the how they communicate. And then we'll need to compile this code. I'm going to use several optimizer actually. Actually, optimizer cannot be decided which one is the best case by case really. I have tried the Adam X. This is what you. Adam is equally adaptive. Forgot the full name, but Adam is quite new. Previously, I just cropped the root mean square propagation, but I tried the root mean square propagation. The result is not fit. I use Adams. The result is good. Okay, much better. Then we use the loss of mean square error. I compare our prediction with the reference. How is the result? So they will need to have very small mean square error to say that this or that is working well. Okay, I'll just press this, and then now I'm going to train the model. What I'm going to train, I'll have the X as the input, Y as the output, and then I'll have several page size 100 times, and then I will take the validation for that set. However, how do we know the model works on predicted something? I'll test, yeah. I'll do prediction as this model is from this. And then this model will do prediction for the X. Okay? What does it mean? Good prediction? How do we know it's not a good prediction? Because when we have the input of 6.9, 8.9, 10.9, the reference will say this one is 12.97. Okay? And the prediction is 12.963. Yeah? So here's a difference here. 12.9 is right, but the rest go still okay. The second one, we have 3.3. Input is 3.3, 5.3, 6, 7.3. Then the reference say this one is 9.34, but predictions say 9.2p. Yep, there is error, but very similar 9.3, 9.2p, and of 9. Scientia. We get prediction of 71.185, but reference say 71.184. Okay, very small difference. Okay. First, remember, we create it first, and then we can have model, we can directly test, yeah? So all the data first will be trained, and then will be followed by the testing. Do you have any question to hear? I will share you.
Okay, let's go and I'll share that. Okay,
Okay?
so
Optimizer is like how to make the model as the prediction as close as the reference. So they push the error as lower. So the smaller the error, the better the result. So they optimize, we lower the error. Sometimes when we try the RNS probe, we cannot have good result. We need to try other or many others. Any optimizer here. I'm not really sure which one is better, case by case. So if you try RNS probe is not good, try other delta. You try other mix. Other mix is quite here. I know the Adam and other delta. And sometimes try error is important. And when we get the error is very small during the training, then this one is the test optimizer. We can select first.
so we'll try a small.
In fact, if we use like the blood pressure, maybe 120 millimeter mercury, then 1 millimeter mercury is good for it. That's 1 out of 1 liters. But if we consider the hemoglobin, maybe normal is like 12 to 15, yeah. What is normal?
Okay, so we have those.
Usually they take like percentage of this. So min to max, you need to see the percentage of. So the one will be to week. Okay, then if there is no any other question, I think we can end the class.